No. Yes, am I officially over? Where am I at? Here we go. Okay, I lost somebody. Anybody have questions from homework? Anything? Homework gets a little weird, but, you know, as always. So if there's no questions, it gets me concerned. Nobody came to office hours, so I guess maybe there is no questions. Does anyone? Any other questions? No? Yes, go ahead, ask.
Okay, I have a question. Okay, I do actually want to go over the percentage error thing.
Okay. Where are we looking?
We're looking 4.3 homework.
Let's see. Okay, and so the margin of error. Okay. Oh, let's see, which screen is it that I can write on? I guess I can write anywhere. Sure. And which problem?
Let me see.
Oh, let's see. I think it's this one. All right, you don't have to be here. Go away. Okay. All right, maybe what's going on now? She's back twice. This is a weird start to the week here, guys. Let's see. All right, now she's gone completely.
Technical difficulties.
Yes, I could tell. So what are we looking at? Do you have a general question like what the hell is it? Or is there a specific problem that was giving you trouble? Or now you're frozen. I feel like you're not there again. Okay. Okay. All right. There she is. Okay. Is there
This is getting
now you're frozen twice. Oh geez. All right. Okay. Is there a number you have an issue with and I can just go over it? Number one. Okay, she's frozen again. Oh, is this like the way this week is going to be? Is this the universe giving me a warning? All right. How's everybody else? You guys okay out there? Are you guys out there?
Yes.
No questions? Everything's
No.
great?
No, not so far.
Okay.
Actually, I was wondering if you could go over number 4 on 4.2.
4.2. All right. Number 4?
Yes.
Okay. All right, Sabrina, you got to hold on. Let me know when you're stable.
Okay, let's just hope this works with my phone.
All right, just a minute. Let me answer this other question. An important artifact is discovered. Oh, no, I guess not. Yeah, all right.
That's my computer.
All right. The only weird thing about number 4 is you have to take into account this. Otherwise, it's just find the distance between these two things. So for example, if I had 2 points that had a distance of 2 between them, how many feet would that be in real life?
Would it be 5 plus 2? I mean, 2 plus 5?
No.
10.
Why plus? Yeah, 10. If each one is 5 feet and I got 2 of them. Yeah, okay. So all you got to do is figure out the distance between these 2 points. And then you got to convert it into real life, which is what they told you this for. Yeah. Does that
Okay.
I mean, that's how maps work, right? If you find a distance on a map, that's not the distance real life. Wow, from here to Minneapolis is like 12 inches. One step and we're there. No, yeah, okay.
It's been a long time since I've read maps.
I understand.
I usually use GPS.
I understand. Normally, yeah, you're right. I remember back in the day, I'd go across country and then have maps of every state that I was going to go through in the car with me. Yeah. Way back in the olden days, before we had the Google Maps and even the MapQuest. All right. I'm going to clear that away. Anything else? Or Sabrina, are you fully there?
Yes, I am. Finally. Sorry for the
Don't feel
technical
bad. It's just the
difficulties.
reality. It's just the reality of how things are today. No worries. We were looking at
Yeah.
3, right?
Yeah,
Which-
4.3, question 1, because I don't think I set it up incorrectly because I looked back at my notes. But after I did this problem, I was like, wait, there is no way this is right. Like I just want to check and see if indeed I got it right. So
This is all you need right here for number 1, right? Okay. And I think some people are having an issue getting it into the calculator. So they're setting the formula up right, but they're not getting it in the calculator correctly. So can you tell me what's p hat?
sample of population.
So what is it in this problem? What's the value? What's it equal to?
90?
No,
Or
So
no, it's
N
0.33.
is 90. P hat is a percentage. It's 0.33.
Yeah.
So then you can do 1 minus p hat will be 0.67, right? And now it's really just a matter of, can you get it in the calculator correctly? Right, so the margin of error is twice the square root of p hat times 1 minus p hat divided by 90. So some people are not getting that 90 under the square root. And that's making a lot of mistakes. So in your calculator, you would do 2 times the square root. Let me see, what would it be? Square root, and it might open a parenthesis. And you don't want to close that parenthesis until you get everything in here. Or you might have a nice one where the square root symbol grows and goes over the whole thing. That would be great, because then you can tell exactly what's in the square root. I don't know, is that helping at all? Is this what you set up for the formula? And then it's just, can you get it in the calculator correctly? No, yes, maybe, no. What's happening? Are you there? Is this what the equation you got?
Oh, sorry, I accidentally did not turn on my mute button. I was talking to the mute button.
Is this
I guess I did input that wrong because I forgot the parentheses.
Yeah, it
Okay.
depends on your calculator, what kind of calculator you got, exactly how the square root symbol works. But on some scientific calculator, they have a square root symbol and then they have a parenthesis, and you got to make sure to get everything in there so it's under the square root. All right. Okay, this section is not like immediately obvious, by the way. So if nobody has questions, I'm worried that nobody's doing it. I know some people have done it because I graded their stuff. So I graded some homework. You want to take a look at it?
Also, quick question.
Yeah.
Is the FPC formula, is that basically the same as the other equation that we were just using?
No. Because the other equation does not have n's or n-1 or big capital N or any of that. So
Okay.
this is in case we're sampling from a small population. So it's a correction that we do.
Oh, okay, I see.
It really, again, it's kind of nice that there's an actual purpose to this formula. They tell you what the formula is for. But even if you don't fully understand what the formula is for, it's just a formula, so I can plug stuff in. I have to know how to figure out what capital N is and what little n is. But capital N is the big group that I'm picking from, and little n is the group that I pick from that big N, right? So big N is always going to be bigger than little n, the number. Yeah. Are you guys, anybody else? So is that okay, Sabrina?
Yes, that's actually great.
So this is what I'm expecting. This is a weird problem. It's weird. This is a weird problem. It is weird. So when I don't get questions, I get concerned.
Yeah.
Either.
Also,
Go ahead.
also with the prep skills 4.4, like the last one where we did the scatter plot, I was so confused of where to put the line.
Oh, you don't. They didn't say to put a line. They just said make a scatter plot. A scatter plot are the points. When they say draw in the line of best fit or something, that's when you do that. They didn't ask for that. Yeah.
Okay.
And there is no line because the shape you should get at the end should actually fit more like this. Not a straight line. But again, don't make that. Just it should just be a bunch of points. Dot, 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 just points. That's all a scatter plot is. It's just a plotting points. Yeah. Is that all right? Yes. Okay.
Yes. Yes. Thank you.
Sure. Any other questions or anybody else questions?
I have one, Professor.
Sure.
On 4-2 for the prep school questions, number 6, I didn't really get that one.
All right. So wait a minute. So the prep skills 4-4-2. Let's see. Like these? No, it doesn't go up to number 6. So you mean
Going
right.
to 4-3, my bad.
I'm with you. I'm with you. Here we go. This one?
Yes, that one right there.
Okay. Did you get number 5?
Yeah, I got that one.
So this is exactly the same. Whatever you did here will also work for this. I want you to realize that. Because isn't this a number divided by n equals a number? Isn't this a number divided by n equals a number?
Yeah, I just you put a question mark on it and I wasn't so sure why.
All right, so what did you do?
Okay, so the 0.027 over n, I multiplied the denominator by n, and then I multiplied the 35 by n. And then all I put was 0.027 over 35. And then that's what I squared, or that's what I put as my answer.
But this is your answer.
Yeah.
Well, that's a lot like putting this as your answer, right?
It's not simplified.
Yeah, you didn't simplify it. Just throw in the old calculator.
All right. I see. I see.
Throw in the old calculator. Yeah.
All right. Thank you.
Sure. All right, good. I feel a little bit better. You guys, yeah, it's sort of like being in this environment makes it a little bit more difficult for me. I feel you can even just make me feel better by just coming up with a question. I know there are questions. I know there are problems that are weird. So when I don't get any questions, I get very concerned. All right, guys. Anything else before we get back into where we left off?
Can you go over number 5 on 4.2, please?
Let's see. Oh, yeah, this one's definitely a strange one. All right. Blah, 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 blah. And then the average car is 14 feet long, and the average length of the cars I could measure the bridge was 34.4 pixels. The length of the bridge is 2,709 pixels. How long is that span in feet? In set up a proportion that compares photo length, blah, 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 blah. So you know that 14 feet is related to 34.4. Do you see that?
Yeah.
Okay, so you can set up a proportion. Let me make sure. Okay, that's nothing to do with this. Good. you can set up a proportion to figure out what the true length of the bridge is. So I know that 34.4 pixels translates to 14 feet. You actually can do this a different way. Well, how can I say this? So you can think of this, you can either set up a proportion. So for example, let me do an example problem. What if on a map, 1 inch was the same as 2 miles? You with me over here?
Yeah.
And on the map, I see 2 towns are 11 inches apart. Well, how many miles are they apart? No, so like 1 inch is the same as 2 miles. So then 11 inches is the same as I don't know miles. You can do that, right? And solve for X.
Okay.
Okay, or, so this is kind of like the standard way to do it, and then you solve. Or you can think of it as a conversion problem. 11 inches. I want inches to go to miles. 1 inch is 2 miles on this map. Remember this good old conversion?
Yeah.
Is anybody okay? Does anybody think I'm insane saying 1 inch is 2 miles? Of course, I'm not insane for that reason. I'm insane for a lot of other reasons. But on the map, 1 inch is 2 miles. I'm not saying in real life. I'm saying on the freaking map. So this conversion holds for the map. If you say map enough, it sounds weird. Map, map, map. All right. So you do exactly the same thing here with pixels and feet. You've got 2 ways you can do that problem now. Is that all right?
Yeah. The only thing is for the first one, is that cross multiply?
Yes, you can cross
Okay.
multiply here. Bam, bam, and then you're done. That's really all with my example. Now this one's not
Okay.
going to be quite as easy because the numbers are a little bit grosser than my example.
Okay.
You know, it's
All right.
often us math teachers do that. Here's an example. It's really easy. No, it's just the numbers are gross and I don't care. It's the calculator. Bam, bam, bam. All right, let me clear all that away. That's a good question because that's a gross problem. I want to say something else too. For some reason, does somebody have a different question than this for number 6, page 483? I know I do. I've got a physical copy of the book too. And my number 6 is not the same as the Kindle version number 6. Do you guys understand what I'm saying? So be very careful. If you are a special person copying from the solutions manual, be very careful that the question matches the answer. Or just don't do that. Or just don't copy. Yeah, that'll make that even better. So yeah, some people's number 6 and 7 are different. I don't know. Nobody's telling me anything. Does everybody have this exact same number 6 question?
I have it.
You have this one with the 89.6 feet?
Yes.
Does anyone have a different question here? I know you do. But you're not telling me. Okay, maybe they're not here. All right. All right, guys. Anything else? We're almost done. You guys know that? Do you guys understand? Do you guys understand we're almost done with the semester?
Yeah, it's kind of scary.
I know, man. We have this week and next week, and then we have finals. What? Hey, Jeff. What? You gonna put up a practice final? Yeah, I will. Oh, okay. And solutions? Yeah, yeah. All right. And have you got insane, Jeff? Yes, I have. Yeah, I've just fully embraced it. Okay. Anybody else? Any other questions? Clean up my beard. Nope. Okay. I got a rogue beard here. It's
Are we completely done with inequalities, or are we going to keep doing those?
inequalities. What do you mean? Sorry.
Like we were doing inequalities last week. We did that worksheet. Did we do?
Inequalities,
No. What
functions.
functions? Yeah.
Sure. Okay.
Did
What-
we keep after that worksheet? Are we going to continue those, or are those kind of put away? I'm just curious.
Well, the book barely mentioned them. So it was my decision to go a little bit deeper into functions.
Okay.
And that's what that handout was.
All right. Just checking. Thank you.
Sure, no worries. Yeah, okay. So yeah, this book requires a little bit of augmentation in a certain few areas. All right, let's see. Where do we leave off? Bam. Whoa. Oh yeah, we're right here. Do with parabolas. Here we go with these angry ducks. All right, let me see. Let me share this. Oh, let me see. Wait a minute. I got to change screens. Hold on. Do. Come here. Okay. So last time we watched that the video. You guys remember? We watched the video about playing darts. Is that how you say that? I guess you don't say darting like bowling. You don't play bowl. So of course they had to bring up angry birds, which they called irate ducks, just to be careful with copyright, because they make beautiful little parabolic arches, parabolic trajectories. These look like the little M&Ms. So we watched a nifty video about darts and how you can kind of use math to predict where the dart's going to hit. So then you can move the board to catch it. So that was kind of nifty. And I stopped in the video where they were going to go into the engineering behind creation of the dartboard. So if you're curious about that part, I can send you the link, or just search "can't miss dartboard." That'll bring up that. And some of you guys knew the guy. He has a lot of other videos. Okay. Blah, 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 blah. Oh, so look at this right here. This is a very nifty question. So parabolas don't only talk about objects in motion. So obviously, oh, I have this backwards, don't I? Dadgummit, Jeff. I had this right the first time. Sorry, guys. Hold on. I got to move you over there. Move this there. All right, here we go. So obviously here they've got, oh, scheisse, I love it. They got this bouncing ball. And if you bounce a ball in a certain way, it's going to create a parabola, right? All a parabola is this, it's a certain curvature to a U shape. It should actually be more like that, maybe. All right. Now, why would it make sense that profit could very likely take on the shape of a down parabola? How much are you going to make if you don't make anything to sell? How much money will you make if you don't make anything to sell?
0.
No money. I love it. So you're going to start at like $0. And then how much are you going to make if you produce too much? If you're like, I've got this thing, I think everybody's going to love it. You make 2 million and then you sell 50 of them. Are you going to make money if you do that? If you make too many, if you produce so many that you can't sell them all, are you going to make money then? Are you guys out there? I'm not trying to make this into a business class. This is the last thing I want to do. I don't care about business. I really don't. Right? Is everybody working on papers? Is that what's happening? Do you have an English paper due today? Is that what's going on? What's happening? I've lost somebody. Help me. If you make too many items and you don't sell all of them, is it possible you don't make any profit?
You don't make profit.
It's possible, right? So there's going to be a position up here. So this is like the number of things you make. So maybe somewhere up here, it's another place where you're not going to make any money. Now, if you start making stuff and selling it, your profit's going to go up. But then you're going to get to a point where you're making too many, and you're not selling all of them. So you, oh crap, and your profit's going to go back down. So it makes this down parabola. And somewhere there's a sweet spot. Somewhere there's a spot where you make the most money possible. Is everybody with me out there? That's why this down parabola shape kind of makes sense. Now, in reality, an actual thing might look something more like this and have several like sweet spots, but let's not worry about that. Normally it's roughly parabolic. So you have this kind of sweet spot. So have you guys ever heard of a position in a business called a financial analyst? Or does those words make sense? Financial analyst. One of my best friends is a financial analyst. He makes upwards of $200,000, $300,000 a year. Of course, he's got 5 kids, so it all just kind of goes away. But you can make a lot of money doing this, because what they do is they analyze the market and they tell people, hey, sell these things at this price, and that should maximize our profit. And they keep analyzing the situation. They keep telling him to change it to this, change it to this. That's one thing they do. Are you guys kind of with me? Because depending on the product you make, all right, and again, I don't want to make, I'm making this way too much into a business class. It's just the last thing I want to do. But depending on the product you make, can't the demand for that product go up and down, up and down? Yes. Over time, don't you want to change how much it costs based on that thing, based on how much is good? Yes. Okay. So that's all that position does basically, is it's analyzing. Okay. Investments is a different thing, but yeah. Okay. All right. All right. So just the idea that the down parabola makes sense for modeling a company's profit. All right. So what would be the point? What place on that parabola, I kind of gave it away already, would be the point that I'd want to have a way to find? Where do I want to be as a company?
The high point.
The high point. I love it. Does anyone know what this high point is called on a parabola? Starts with the letter V.
Vertex? Question mark.
Vertex! Exclamation point. I like it. Does that sound familiar, that word vertex?
It does.
It does. And it's not vortex. Be careful. It's not a polar vortex, right? It's a vertex. Okay, I like it. Okay. So let me clear all this shit away. And I'm sorry, I went a little too deep into business. I am so bored with business. I can't. And you guys are like, business plus math equals supreme boredom. I'm sorry. Let me clear all this away. And by the way, if you love business, I'm not shitting on business. Have a great time with it. It's just not for me. Let me see here. Oh, shit. Yeah, I mean, some business classes can be fun. I agree. I very much agree. Personally, most of them suck for me. It's just me. All right. So we got a homeowner wants to build a place for his dog Moose. To each their own. He decided he'd like to spend no more than the cost of 160 feet of fencing, right? Since he wants Moose to have plenty of room for chasing squirrels, he decides to use the full 160 feet. Everybody with me so far? He's going to use a full 160 feet to make this fenced-in area so Moose can go out and chase squirrels. He wants it to be rectangular because that's his favorite shape. So screw this full sentence bullshit. If he decides to make the play area 5 feet wide, all right, let's play around with this a bit. Come on now, just stay with me. This is not going to be too crazy. If he makes this 5 feet, how long would it be? So he's got 160 feet to play with, correct? Can you take a minute and figure out how long would it be if he made this 5 feet?
Would it be 32 feet?
No. 32. How did you get 30? Did you divide by 5? Oh, you divided by 5. Dividing by 5, I'm not cutting the 160 feet up into 5 parts. That's not what I'm doing. This is 5 feet. So what's this?
5.
5 feet. How many feet have I used so far?
10.
How much do I have left?
150
And
divided
I
by
have to
2
make these two
75.
sides, right? Sorry?
Yes, would be 75.
Good. 150 divided by 2 is 75 feet. Did anyone not follow that? Let me know now. That was a little bit quick, so just let me know if you didn't follow the idea. Here's a really cool way to do this. I really want this to make all the sense in the world. If I want this to be 160 feet total all the way around, how much is it if I go halfway? How much is it if I just go from here to there? How many feet is that? Come on, you can do it. If it's
80.
160, sorry?
80.
80. So now look at this. If that's 5 feet, this has to be 75 feet, of course, right? Do you guys see that? That's a quicker way to get it. No? Too much for a Monday morning? What the shit, Jeff? Does everybody agree with me that if it's supposed to be 180 all the way around, isn't this going to be 80 feet? Isn't that going to be 80 feet if it's supposed to be 160 all the way around? Yes?
Yes.
And if that's 5, that means this has to be 75. So there's 2 ways to answer that first question. Thankfully, both ways come up with the same answer. Okay, nothing crazy so far. Can somebody tell me what is the area of this? I'm pretty sure that's going to be their next question. What is the area of this if we make it to these specifications? What's the area of this rectangular area? The area of the rectangular area. Come on, you can do it.
375.
How'd you get that?
75 times 5.
Of course, yes, it's 375 square feet. So area is length times width, always for a rectangle. I love it. All right. Nothing too crazy yet. What if, let me kind of, I'm going to guess where the book's going to go, and I want to do it right here. What if we were instead to make this, well, maybe I should just go 375 square feet. No, I want to do it here. Screw the book. So what if that was 10 feet? Can somebody please tell me what this side, what the length would have to be then? If I make the width 10 feet, what's the length got to be?
70.
Is everybody with her? So the shortcut is these have to make 80 to have 160 total all the way around. If that's 10, that's got to be 70. What's the area of that now?
700.
700. Which area would my dog probably prefer?
To 700 square feet.
Hell shit, yeah. Damn straight. Have I used any more fencing to make the area bigger? Did I use more fencing to make the area bigger? Didn't we use the same amount of fencing? 1070, 1070 would make 160. Isn't this 160 also? Are you guys with me? Are you guys understanding what's happening? If I change the dimensions, that doesn't mean that I'm using more or less fence, but it does make larger area. So what do you think I'm going to try to do with this problem? I'm going to try to figure out what are the dimensions so I give my dog the largest possible area to play in. Because I'm a good dog owner. I want my dog to be happy. All right, let me clear all this away. Let's see if I was guessing correctly as to where they're going to go next. Okay. Oh yeah, they went a little bit further. What would the length be if the play area is 50 feet wide? So let's try this out. So if the length, I'm sorry, what does it say? What would the length be if the width was 50 feet? Well, this is kind of dumb. What would the length be?
30 feet.
30. And then what would the area be?
Hundred 50.
Almost. 3 times 5 is 15, 0, 0. 1,500, dude, that's nice. But is that the biggest we can make it? No. All right, so I don't know. Are you guys able to finish this? So like, for example, this is what we did earlier. 5 feet width means 75 feet length. I don't know why they don't have their units on there, which makes it, what was this? 375 feet square area. Right, so a 5 foot width leads to a 375 square foot area. You guys with me on how to fill this thing in? All right, everybody who's here with me, please go ahead and keep going. Keep going, keep going. This shouldn't take forever. You should be able to do this. Just to make this quicker, what do the width and the length together have to make?
160.
No. 2 widths and 2 lengths have to make 160, right? 2 widths and 2 lengths.
Oh, 80.
So 1 width and 1 length makes 80. That makes it so much quicker. If that's 5, that's 75. If that's 10, this is what we just did a minute ago. That's 70, right? Which makes 700 square feet. 10 leads to 700 square feet. All right, keep going. Go ahead and fill in some more. And let me make my regular plea. If anybody else is able to turn on the camera, that'd be great. If not, you're fine. If not, you're fine. Thank you, Caitlin. It just does wonders for my psyche. You're fine. Like I said, you don't have to turn your camera on. I'm never going to force you until it's the final, in which case you better turn your damn camera on. But normal class, you're fine. You don't have to. Okay, I'll shut up. Go ahead and finish that. Yeah, okay, you got the idea. So then this will be 60 feet. This will be 1,200 square feet. So 20 width leads to 12. What the hell's that, Jeff? 1,200 square feet. Yeah.
And
Right.
then that one would be 50.
Good.
And then, yeah.
So the area he has to play in is still increasing. Dadgummit. And then this is 40, right? That leads to 1,600 square feet. 40, 1,600. But then when you do this one, has anyone done this one yet?
He starts losing area.
Yeah,
Right.
which kind of makes sense because it should be the same as this, right? So now I have less work to do because I know what's going to happen. This is going to be like 60, 20, 1,200. All right, so that should be enough. So watch this. All right, you guys have to help me. I need some help. Please assist. What should I make this scale to plot this?
10.
By tens, I like it. Yeah, the 5 one we can just estimate. So 10, 20, 30, 40, 50, 60. All right, that's plenty. And then what should I do? This one, oh shit. What should this one be? Oh shit. I've got to be able to go up to 1600. There's 1, 2, 3, 4, 5, 6, 7. Well, if I just go to 8. You see how I'm
200.
doing? Go ahead. Yeah, 200, exactly. You count how many tick marks you want to use, divide that into how high you want to go. Bless you. So this will be 200, 400, 600. Okay, Jeff, I think they get the idea. 1200. Oh, you're still going to say it? Yeah, I'm still going to say it. All right. So then 10 goes to 700. 20 goes to 1200. 30 goes to 1500. 40 goes to 1600. And then it starts to repeat. It starts to be like a mirror image. Do you see that? So there's a mirror image there. There'll be a mirror image there. All right, that's plenty. And of course, 0 would be 0, right? So up it goes. Whee! Oh, shit, Jeff, what happened? I don't know. All right. So this is the sweet spot. That's the sweet spot. Now listen to this. Do you guys believe me when I say that if you want to make a rectangular shape, the way to make the area the biggest is to make it a square? What was the biggest area? What did that correspond to? When the length and the width were, the biggest area corresponded to the time when the length and the width were
Equal?
equal, which means it's a square, correct? All the sides would be the same. That makes a square, doesn't it? Come on, you guys can do it. You guys can do it. Listen, go with me, go with me. This is so freaking cool. Go with me, just hang out. Has anyone ever seen like a grain silo? If I say the word silo. Anyone ever seen a grain silo or any kind of, no? Does anyone know what it is? What a silo is? All right. Well, shit, I can't, all right.
Well, I do.
You do, aren't most of them like
Contain
cylinder?
grain.
Huh, sorry?
Cylinder.
They are a cylinder and they mostly contain like grain, water, fucking shit.
Yeah, like corn and stuff. Isn't there
Yeah.
one in, has anyone ever seen that movie, A Quiet Place? Do you remember when they fall in and there's all the grain in there and they're sinking in the grain and the monster comes in there and he's like, all right. And then the dad has to, why did he have to, all right, sorry. All right. Just in case you haven't. Why is that? Real quick. I'm going a little bit further than the book does. Yeah, fam. Okay. If I want to make the biggest possible area, I make a circle. Now, a square is better than any other rectangle, but a circle is the best one for having a larger area for the same amount of perimeter. So that's why so many things that have to hold little things like grain or something, they're going to be circular as they go up, because that gives them the biggest volume for the least amount of material. And then you can save money. Are you guys with me? In your free time, just Google silo. Maybe even put grain in front of it, grain silo, or peanuts even in a silo. I'm a Georgia boy, so I think about peanuts in a big old silo. All right, enough of that, Jeff. Okay. Excusez-moi, hold on. Yummy. All right, so this is a naturally occurring parabola. It does not show something moving, correct? I didn't throw a ball up. This is just how the area changes as I change the dimensions of my rectangle. Okay, so let me clear all this away. So it's just another place that a parabola can show up. Clear. Blah, 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 blah. We said all this shit. Okay. Oh, okay. All right. Hold on. Let's see. So let me ask you this. Write an expression with W representing the width to describe the length when the width is W feet. Okay, that should be pretty easy. When we made the width 5 feet, what do we have to make the length? Remember just a minute ago, when it was 5 feet, what was the length? You can look back up. Hopefully you took notes. I don't know.
75.
Say again? 75. Because it's 160 total, so it's 80 halfway around. So if I call the width W, how do I figure out what the length is? If the width was 10, what would the length have to be?
70.
70. What did you do to figure that out?
80 minus the width.
Yeah, so
So-
80 minus the width. Perfectly said. I love it. So if the width is something, the length is 80 minus that thing in this problem, correct? Not everywhere in the universe, but in this problem. All right, I love it. Stay with me now. Is anybody have trouble with what we just did here? All that's doing is capturing what we did. The shortcut we did to figure out the length. Okay, now, in general, what is area of a rectangle? What's the formula for the area of a rectangle?
Length times width.
Length times width. The width is W. What's the length?
80.
No,
75. Jesus.
no. I didn't say the width is 5. I said the width is W.
Oh.
What's the length?
80 minus W.
There we go. Okay, wait, let me stop for a minute. You're fine. You're fine. So again, it gets weirder, and this is why I wish I could do this a different way. If you look up, I don't know if you took notes, like a good student would, but we had 5, 75, and then we could figure out the area. We had 10, 70, 20, 60, correct? Didn't we then multiply these two together to figure out what this was? Of course we did, because that's the formula. So what if the length what if the width is W and the length is 80 minus W? We would still multiply them together to figure out the freaking area. Of course we would. That's the point where students kind of lose it a little bit. All this right here is doing is saying, what would I do if I knew the width and I knew the length? I would multiply them. What would I do if I knew the feet squared? I guess I should put them. What would I do if I knew the length and I knew the width? I would multiply them. Okay, what would I do if I knew the width and I knew the length? I would freaking multiply them. That's all it says. Okay. Now watch this. How do you simplify this? What would I have to do to simplify this? What can I do? Don't overthink it. You may put the W out front. Maybe that looks more normal. What do you do there? You know it. You know what to do. Tell me.
80 W
Yes.
minus
Good.
W
Minus what now?
W squared.
W squared, 11. So you distribute the W. Of course you do, right? We know that. Something's sitting out in front, you take it through. Is this linear? Is this linear? Why not? It is not linear, correct. Why not?
There's
Because
an
W
exponential
squared.
number.
It's got a higher power than 1. It's got a different power than 1. To be linear, every variable has to have a first power. This has a square. It's not linear. That's why it's curvy. It's curvy. And do you see how the W squared part has a negative in front of it? That's why it goes down. If this had been a plus, it would have gone up. Everybody with me? If that's negative, it makes it sad. If it's positive, it makes you very crazy happy. Okay. No, yes, maybe, no. Okay. I'm gonna clear all this away. You guys are really loving this. So now we're making the connection. We already made the picture, didn't we? We drew the picture up above. Let me take my little dude away. Did it not look like this? Yes, it did. When we drew the picture, it looked like that. That's what goes with this equation, right? You have an equation, and then you have a visual representation of the equation. That's what a graph is. We graphed the thing before we even knew what the equation was, because we're so cool, right? But now we know what the equation is, and that's what its graph looks like. All right, let me clear all this away. Here it goes. Clear. So real quick, if I had an equation like this, is this going to look like A this or B this? Which one is it going to look like?
Like A,
It'll look like A. Why?
because of that positive.
Plus 11. So if the squared piece is positive, it's going to open up. The squared piece is negative, it's going to open down. I like it. We call this cup up and cup down because it looks like a cup. So if it's positive, it'll hold water. If it's negative, it won't hold water. It'll all drop. Ah, shit. Okay. Let me clear all this away. Boop. Oh, look. Oh, sorry. Look at this. This is so nice. So here we have the profit for a wind turbine company. The first coordinates represent the monthly number of kilowatt hours of electricity generated by the turbines. All right, so here we go. So this is a little bit confusing. Let me see. The second quarter of the company's profit. So that this company manufactures wind turbines, but this is the number. All right, we're just going to go with this. I think this is an electric company. So this is how much electricity they generate and how much money they make. So what is the y-intercept of the graph and why does it make sense? Can you estimate, somebody estimate for me what the y-intercept is?
$240,000.
240. All right, so what you just did was you estimated the vertex, is what it sounds like to me. I want the y-intercept.
Negative 60,000.
All right, and now make it, so of course, real quick, an intercept is a point. So it'll be negative 60,000. It sounds like a good estimation, right? And what does that tell us? What does that mean in the real world? When they then they I love you guys. What does the X mean? What does the X measure?
Profit.
No,
Millions of kilowatts per hour.
that's what the X-axis is. What's the Y-axis?
Profit.
Profit. So when
they're not producing electricity, they're losing money
yes, why does that make sense?
because if they're not producing electricity, nobody can buy it.
Good, and they're not making the money back that they spent making the turbines in the first place, correct? So apparently it cost them $60,000 to set things up. And then they have to sell so much energy to recoup their money. Does that make sense? Does anyone remember what this point here is called? Right here. Why is that point? All right, it's the x-intercept. And that's the next question. But what does it mean? There's a special break-even point. That's when they sell enough electricity to make back the money they had to pay in the first place, right? It's sort of like if I go buy an ice cream cart and then I buy ice cream to put into it, I'm already in the hole, correct? I've got to sell some ice cream just to get back up to zero. Yay, I am at zero. I mean, that's a big time for, and then if I sell any more, then I'm in the money, I'm in the profit. Yay. All right. And if I don't sell it, I just eat it. Oh, geez. All right, let me clear this away. So that's what number 12 is all about, is the break-even point. How much do I have to sell or generate and sell in order to make a profit of $100,000? This is an interesting question. How much electricity would I need to generate to make a profit of $100,000?
Approximately 60 million kilowatts.
Well, let's see, 67,
Approximately.
I thought
70.
it was like 75.
Yeah, it's a little above 70. Okay, sure. Is that the only answer?
No,
Right, there's this, the whole thing about parabolas is their symmetry. They are mirror images of themselves, right? So there's another point right over here. It looks to be roughly 360, 370, 380, right below 380, right? Okay, all right. I have no idea how you guys are doing. Let's see, blah, 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 blah. What's the max profit? Now, somebody's already answered this question earlier. What's the maximum profit they can earn? Roughly.
240,000.
Yeah, like 240 something. And when does that happen? Looks to be right in the middle of 200 and 250, right?
Like
That looks to be,
230.
yeah, like 225 something. So that looks to be their sweet spot. They want to try to get here so that they can maximize their profit. I like it. Okay, all right. So too much business shit. Let's see. Ooh, yeah. No, we're not going to do that. So official name for a parabolic graph producing function is called a quadratic function. Now, what does quad mean? What does quad mean?
4.
And what's the highest degree in this thing? What's the highest power?
2. The ax squared.
Yeah, so what's up with math people? What the shit? I thought numbers were our thing. Why do we call this a quadratic function? Because
4 variables.
no, there's not 4 variables. These are all numbers those are all numbers. Because how many sides does the square have? 4. And what's the area of it? X times x squared. So that's one reason why they decided to call it a quadratic function, is because one place it comes from, like we had the dog thing earlier, it comes from rectangles, it comes from squares, it comes from 4-sided figures. Okay, just in case somebody eventually thinks, why the hell are they calling these things quadratic? All right, that's one. So tell me this. So they have to have this form to be quadratic. Which one of these is not quadratic? How many of these are not quadratic? Can somebody pick out one that is not? Are any of these not quadratic? Are they all quadratic?
B.
B is quadratic. All right, real quick. Do you guys see? A is the number in front of x squared. So in part B, what is A equal to? What is in front of x squared?
Oh, the understood one.
Yeah, -1. And what's B? What's in front of the x?
8.
8. And then what's C? Is there a number out there by itself?
No.
No, so it's 0. So it's good. So A can't
So
be
then would it be
0.
C?
Sorry?
Would it be C because it has the cube
Is
in there?
not, I like it. Not. Why is C not quadratic? Because I think you just said it, because it's got a third power. That's not allowed, right? There's one more that isn't quadratic.
Would it be E that has the square root in there?
Exactly, good, right? And this one, in case you thought if you multiply it through, you do get 2x squared minus 8x. So that is quadratic. So D
Yes.
is the other one that isn't. Okay, I love it. Are you guys doing okay? I have no idea. All right, so let me clear all this away. So to be quadratic, you have to have an x squared term, obviously, and that's the highest power you can have. Okay, let me clear all this away. You're not allowed to have square roots and stuff. That's a whole different beast. Fantastic math beasts and where to find them. Okay, okay. So let's take a look at what the homework is going to kind of look like here. So obviously they're going to give you, so this is a real throwing something problem, right? You got a football. We're assuming there's no air resistance. That would change the parabolic arc. And they're going to ask you some questions, right? So that should be expected. Nothing amazing there. Another football thing. So I'm sorry if you hate football. You can pretend it's something else. Are they just going to talk about football? I think so. Yeah. All right. The whole thing is about football. So again, sorry if you hate football. So what we're, so hopefully that section is not too horrible. You're going to have to interpret some stuff from a graph. That's going to happen. Let me see. Oh, let me see one thing. Hold on. Sorry. Yeah, here we go. I love it. Somebody was asking about function stuff. So now it's just going to kind of come up whenever they want it to, right? So there's function notation right here. So we went over that handout just to get a little deeper appreciation about what functions are. But the book's not going to go quite that deep, but it just, every time you see it now, you shouldn't freak out. Let's look ahead a little bit. We are approaching some of my favorite stuff. So we're going to have to go through some algebraic manipulations of things. We're going to talk more about business. I'm sorry. Revenue, cost, and profit functions. Oh my goodness. But then we're finally going to get into the really, really good stuff. I'm sure you're all going to agree with me. Factoring. We're going to get into factoring. That's in section 4.9. Yeah. Sweet. Oh, very important thing I want to talk about real quick, and then we'll call it a day. Let me see. Where's my canvas at? Oh shit, what have I done? Okay, stop sharing. Whew, I thought I deleted everything. Hold on, guys. When is our next quiz?
Is it this Thursday?
All right, why would you say that?
That was actually, honestly, that was just a guess because it's been 2 weeks since our last one.
Understood. So here's the thing. Do you see this? So I had wanted to make it tomorrow, but since I did not announce that, I forgot to announce that last week. We're going to make it, let's see, what is May 19th? We're going to make it Wednesday. So it's going to go over 4.1 to 4.5. You guys all with me? 4.1 to 4.5. Wednesday. So if you haven't done those, I know the due dates I think were yesterday or whatever for the last couple, but you still can get it done. You can still turn it in, of course, as always. I don't know if we're going to do quiz 7. We'll see. Maybe I'll just we'll figure it out. And then of course, here's where the finals come in. So I've got 2 days worth of review for the final next week. Like I said, I will have a practice final. I'll put that up this week. So that'll be part of what we can go over. So that's what's happening. So Wednesday, May 19th, this Wednesday is going to be our next quiz. Cool. All right. And of course, next Monday, is it next Monday? No. 2 weeks from today is a holiday. All right, and that's enough. I think that's enough for today. So let me know if you need to hang out. Otherwise, we'll go running, screaming away about, I thought this was math class, not business class, Jeff. I'm sorry. Let me know if you have any
Thank you,
questions.
Professor.
Sure.
Thank you, Professor.
What
Have
do-
a good one.
What do you think will be the toughest thing on the final?
I mean, everybody's going to have their own thing.
Difficulty, yeah.
To be honest, factoring is widely regarded as a difficult thing. I'm hoping to break it down so it's not so crazy. But considering it's the last thing we do just about, and I've made it so that I got 2 or 3 days I can kind of focus on it. But I don't know. It really depends on each person has their own stuff that they think is really difficult. Yeah.
Okay, awesome. Can we also like go through another percentage error kind of thing? Maybe.
Let's see. Do I still have the book
Because
open?
like because it was like one of those things where I completely understood it during class, but then I go back to the homework, I'm like, yikes.
All right. That was 4-3. Sorry.
Yeah.
So with number 1, did you try to do it again and get the right answer or no?
The thing is like I thought I had it wrong, but then I had it right. But the thing is like I kind of forgot to put the parentheses in the calculator because I didn't write it out that way and I should have
Okay.
just to remind myself, but I
Okay.
didn't, so that was my fault.
Okay.
But yeah, like what about like the give or take sort of thing? Kind of sort of don't understand that part.
Like number 2.
No, it's like the confidence, like the confidence
Sure,
interval.
sure.
Like that kind of I don't know, it kind of messes with me. Like I completely understand it, then I don't.
All right. So if you
Kind of
calculate,
look back on it.
all right, let's do, well, so number 1, if you try to plug it back in the calculator now that you've got things set up correctly.
Yep.
So tell me what you get.
Okay, so put all that in parentheses. Got it. 0.33. Or actually, let's just do this. Don't do bracket.
Get about 10%.
Yeah, which is what I got. No,
Okay.
I got 1%.
Uh-oh.
Then the next one I got 10%. I got 10% for the answer number 3. So I definitely put something in wrong on the calculator. That's what
Yes.
had me.
And I'm almost certain that the 90 didn't end up getting into your square root. What kind of calculator are you using? Scientific calculator? Oh, it's okay. So,
Basically the same one you got.
all right. Let's see.
Um,
Hold on. Let me open my calculator up.
okay, 1 minus 0.33.
See, that's why I do that.
Parentheses,
I do that first, so I don't have too
And
much
then
stuff in my
divide that
calculator.
by
So
90.
all right. 2 times.
I have a very dumb question.
What's up?
Would it still work if I put it in like this? You can see it?
Hold on. Hold it right there.
Holding it.
It's too, I can't see it. It's too much.
Okay. Let me see if I could do this. Flip the view screen.
All right, there we go. 0.331 minus.
Like those little bracket things, would that still work with
Oh, I
the-
see. Yeah, you have one that grows the square root symbol. So hit enter. What do you get?
Enter.
Just hit, yeah.
Got it.
What do you get?
Okay, it came out like that.
Show,
So I
no,
don't
I
know-
can't see it. I can't see it. Up a little, up a little. There we go. 0.099. Okay. I have no idea why a calculator puts that in parentheses or whatever. Yeah, so 0.099, so 10%.
Because I selected like the K thingy. You see like the parenthesis here.
Oh, okay, whatever. So you got 10%.
So-
Perfect. That's the right answer. Okay.
Okay.
Yeah.
I probably just put it in my calculator wrong. Or something screwy
Now
that I
watch,
did.
now watch. Here we go. So they found, so you just figured out, what are you doing? You're weird. What is going on? Hold on, there we go.
I love
That's-
technology.
look at that. That's weird. Hold on. What have I done?
That's a fancy W.
What's going on?
A square grid.
Ooh, what is that? Neat. Wait a minute. No, all right, there we go. Now I'm going back down. There we go. Oh, I had no idea I had that much control. That's awesome. All right. Okay, so they found 33%, and we just discovered it's give or take 10%, right?
Yeah.
All right, so what's 33 take away 10?
That's 23.
23, and what's 33 give 10?
That's 63. No, 43. Sorry.
Yeah. So
My bad.
then we are 95% confident that this interval contains the real percentage of students opposed to the policy.
Wait, how do you
How do I
get to did you say like 90% confident?
95% confident. So the whole thing,
95%
this whole-
confident?
everything this is based on. All right, let me go back up here. All right. When n people are polled and p hat give a particular response, so the 33%, the margin of error with a 95% confidence level is given by the, so we are 95% confident that the interval 23% to 43% contains the real percentage who oppose the policy in that problem, right? This whole thing is built off of, and I told you that number 2 is related to us wanting to be this confident. If we wanted to be more confident, that 2 would go up. It would become 2.5 and then 3. If I wanted to be less confident, the 2 would go down.
Okay.
So that 2 is because of the fact that I'm 95% certain. So anytime you create a confidence interval with this formula, you're 95% certain about your interval that you created.
Okay.
So I'm sure that they have. All right, let me see. Hold on. Oh, here we go. And the margin, this means they're confident that the actual percentage of Americans is somewhere between, they actually wrote that backwards, but oh well. The polling institution is 95% sure that this interval contains the true percentage of Americans that like pizza. I mean, so there's a couple of examples where they tell you how to interpret an interval that you create.
Okay.
So it's kind of like from just 90 students, they found this percentage. So is that the right percentage for all students? Probably not. Where is the right percentage for all students? Well, I'm 95% confident that between 23% and 40%, I can find the real percentage of all students. So it's all about the fact that that 33% came from a sample. So it's probably not the right percentage for everybody.
Okay.
So we're 95% confident that 23% to 43% contains that real percentage of everybody. Yeah.
Makes sense.
Maybe. It's a weird idea. It is. But it's just better than giving somebody a number, giving them an interval instead.
Yeah, to me the idea makes sense to me. It's just how you get there that doesn't make sense.
Yeah.
You know what I mean?
But this is nice. You
Yeah.
figure out the plus or minus amount, and then you add and subtract it from what was discovered, and then you've made
Oh, I see.
So that's how I got 23 and 43. It's because they found 33 and we're like, we think you're off by 10%. So that's why
Okay.
it's anywhere from 23 to 43%. Yeah.
I see. All right, awesome. Well, thank you, and I'll let you go.
Okay.
Professor,
Yes.
I just had a question. Well, I just want to remind you, just in case you forgot, because for my midterm, I don't know if you remember that you said I used photomath, and then you ended up saying you would grade it. It hasn't been graded, and since the semester's about to end, I just want to make sure I have time
Oh,
for
I'm sorry.
corrections.
Yeah, hold on. Let me pull it up my screen so I can do it in between my meetings. Let me see. Hold on. All right, let me pull it up here so I don't forget. Where'd it go? Here we go. Midterm submit. Here we go. Bam. All right. So where are you at? Okay. So here we go. Where are you? I didn't grade it. Wait a minute. Oh, I haven't. Okay. Okay. I see. Here we go. I need to regrade it. That's right. I haven't looked at it. Okay. I'll do that today.
Okay, thank you very much.
You're welcome.
All right, bye.
Okay, and one last thing.
Yeah.
Actually, two last things.
Yes.
What does the quiz cover on Thursday?
4.1 through 4.5.
Okay. And the other last thing is that I will be correcting all my quizzes and the midterm. So just to give you a heads up.
Okay. I'm
Yeah.
hoping over the next, well, before the final, I want to get everything, all the corrections to quizzes and midterm graded.
Okay.
Because then I can tell you, here's what you need to make on the final to pass and do other things, right?
Okay.
Yeah, so hopefully
Awesome.
I'll find some time to catch up on grading corrections. Yeah.
Okay.
Okay.
Thank you, Professor. Bye.